Alright, for example 2, here is our given function, and again it's defined, I guess in this time by 3 points, and they're connected. And our instructions are to graph y is equal to f of 2 of x, and y is equal to f of x over 2. It's a little bit different. Last time we were graphing y is equal to 2 times the f of x, right? And that was, if you remembered, that was a vertical stretch. So now when we're graphing y, you see the 2 is inside of the function. And so this is going to be make a horizontal change. So for the note here, I'm just going to say that I'll simplify it. Really what we're going to do is we're going to multiply the x values by the reciprocal. So for this example, we're going to be multiplying our x values times a half. For this one, we're going to be multiplying our x values, well, this is the same thing as saying y is equal to f of 1/2 times x. So the reciprocal of a half is equal to 2. And here the reciprocal is equal to 1/2. So we're going to be multiplying by the reciprocal. So why is that? Well, you'll recall before when we'd had, say, y is equal to f of x minus h, okay? Or even if I put a number there instead of a variable, let's say if I did x minus 3. My explanation is that we had to add 3 to our new function so that to sort of compensate for the fact that we're going to be subtracting 3 from it before it goes into the function. So what happens inside of here when we do these translations and the things that are happening to x, we have to compensate for them. We have to, add 3 to the x values first to get the same y value. Here, if the x values are going to get multiplied by 2, we better start off with an x that's half as much in order to get the same result. So we're going to be here we add 3, and here we're going to do multiply by the reciprocal. Instead of 2, we're going to multiply by a half. Here, instead of multiplying by a half, we're going to multiply by 2. Okay, so let's figure out our x's and our y's and all that good stuff here. So in our table of values here, we're going to have for our x and our y, which is just our straight ahead f of x. Looks like we got looks like we have a -2 and a 0, and then we have a 0 and a -2, and then that last one is a 2, 2. So now in my y is equal to f of 2 of x, I'll have my x's and my y values, f of 2 of x. So I'm going to multiply my x values. In this case, I'm going to multiply them all by a half. So instead of -2, 0, 2, I'll have -1, 0, 1. But my y values of 0, -2, and +2 stay the same. So I get 0, -2, and +2. So what happens to my shape here is the one for reference. That was my original one. Kind of goes like this. And here. And this one goes like that. So when I draw the line, kind of goes like that. So you can see that this will be a horizontal compression. Okay, and for this one here, when I'm going to be multiplying by 2, my x values, or my y values are going to stay the same. But now my x values, instead of -2, 0, and 2, those will get doubled. -4, 0, and 4. And you'll see how we get our Instead of negative 2, we'll get a negative 4. This point stays the same. Instead of 2 here, we get 4. So we get, see if I can make this line nice there. If we go, get something like that. So this is a horizontal stretch. So it's a little bit different than before. You remember for our last page, our summary, we said that when the absolute value of a is greater than 1, then you're multiplying the y values by something greater than 1, and that's why you get a vertical stretch. In here, because of that reciprocal nature, it's the opposite way, isn't it? So we can say if the absolute value of b is greater than 1, then it's a horizontal compression. And if the absolute value of b is less than 1, then it is a horizontal stretch. Alright, I have a your turn to work on. And so just a quick reminder here, we'll give ourselves a little note here, that if you have a y is equal to a f of x, then we multiply the y values by a. And if you have y is equal to f b of x, then we multiply our y values, our x values by the reciprocal of b. So it seems to me that in this case we have a b of 3, and in this one looks like we have an a equals 1/4. So there is f of x, so I want you to sketch g of x and h of x. So I'll pause for a few seconds. I want you to hit pause on the video, try those two out, and then see how you did. Alright, this is what I instead of using all that nice white space at the bottom of the page, I just put it right on top. So my g of x, where I'm multiplying all my y values by 1/4. So you can see in my blue g of x function, it really flattens out. That would be a vertical compression. And now in my h of x, I did in green, and I'm dividing all my x values by 3, so it is a horizontal compression. So they're both compressions. H of x in green here is a horizontal compression, and the blue one is a vertical compression. All right.